Alright guys, good morning, or afternoon, or whatever it is for you. Today, we're going to make a simple concept immensely overcomplicated. This is one of my favorite things to do. So, back in learning arithmetic, you might come across a problem like this, where they ask you to multiply a negative number and a positive number. And it's pretty easy for you to multiply these two numbers. You know that's going to be 6. What do you do with a negative? And you learn that if you have just one of these negative and one of them positive, then the final result is going to be negative. But then you also learn that if both of them are negative, the final result is going to be positive. And some people find this very difficult to grasp. It's kind of a tricky concept to think that you would start with two negative things and end with something that is positive. So today I'm going to take this concept and I'm going to make it way more complicated than it needs to be and create an explanation, a diagram that will allow you to visualize why this happens. So first let's start with addition. Addition is pretty simple. We can just do it on a number line, right? So we're going to let 0 be here. And I'm going to make a couple ticks here, 3, 4, 5, and we're going to -1, 2, 3, 4, 5. So if I want to, say, add some numbers, let's stick with the 2 and 3 theme. So if I start at 2, right, and I want to add 3, I'm simply just going to, count over 3. And that's going to end us at 5. We've all done this. This is a very simple concept, right? But if we want to multiply numbers, then we need to go one step further and add a second axis. So what we're going to do is we're going to come right here, go up, and right here and go down. This is pretty ugly. And then make some tick marks. And you may recognize this mess as the Cartesian plane, which is absolutely excellent. So now let's, instead of adding 2 and 3, let's multiply 2 and 3. So let's do 3 on one axis, right? So we're going to go over 1, 2, 3 right here, and 2 on the other axis right here, and we're going to multiply them. And that gives us this whole area, which is the value of the multiplication. To be more precise, it's the absolute value. So the area within there is the absolute value of 2 times 3, right? And the reason that's important is because we can't really represent negative area. Well, not yet. We don't really have a negative area idea. So make sure you know that the area is the absolute value, and then we need to determine the sign somehow. And that's what I'm going to do today with this diagram. So we can realize, we know that this right here is the x-axis, right? And this is the y-axis. So we can represent this multiplication as two components. This is going to be the change in x, the delta x from the origin. This is going to be the change in y, the delta y from the origin. So the area, which is the same thing as the absolute value of delta x, delta y. And that's basically what we did right up here. And then what we want to determine is whether this is positive or negative, delta x, delta y. And how can we do that? Well, let's recall what we know about Cartesian algebra. So we can multiply here, but additionally we've created a point, right, represented by these coordinates of delta x, delta y. This point is delta x, delta y. And we can draw from the origin to this point, and we have created a line. And how do we describe this line? We could create a function for it, right? And since it's centered at the origin, the y-intercept is just 0. So it's going to be y is equal to something times x plus 0, right? And we determine the multiplier of x by the slope, right? And slope is the same thing as delta y over delta x, which we saw right here. So that means that we can determine the slope of this line by simply taking this value divided by this value. So it should stand to reason that if we divide two values, delta x, or delta y and delta x, and we multiply them, the values are going to be different unless we're dealing with just a bunch of ones here. But they ought to be the same sign, right? The sign should not change. So that means that the slope should have the same sign as the answer to the multiplication problem. So that is, if the slope is positive, then the answer to the multiplication problem is also positive, right? So simply, in this diagram, we need to take a look at the slope for any given multiplication problem. So here we can see that this is quite clearly a positive slope. That's what we would expect from multiplying a positive number and a positive number. However, if we move over here into the second quadrant and multiply, say, -2 by +3, we have -2 is our delta x and +3 is our delta y. And again, there's our point. The slope of the line is negative. And that goes with what we saw earlier. The result of multiplying these two numbers is negative. So then that really leaves us with the third quadrant. The fourth quadrant is basically just going to do the same thing as the third quadrant, as you would imagine. So we're going to take, say, -3, right? And -2. -2 is our components. Multiply them, -3 by -2. And this is our point. If we draw the line to the origin, we see we have a positive slope, which meets with what they teach you in school as two negative numbers giving a positive result. So using this diagram, you can represent any multiplication problem and easily see this line simply by the slope of the line. When you shouldn't have to do that. You should probably already know this, this concept by now if you're watching this. If you want to think of it in a more intuitive way, you can think of the negatives as direction changes. So this makes movement go backwards. And then if you go backwards again, you're going forwards, right? So if you turn around, if you're walking down the street and you turn around, right, you're going backwards. But then if you turn around again, you're going forwards. That's kind of the intuitive way I think about it in my head. But this is also a overdone mathematical way you can think about it. So thank you guys so much for watching, and I will see you in my next video.